Earth almost tore itself apart, and humanity never knew how close it came. For most of human history, Earth has appeared solid, dependable, and unchanging. Mountains seemed eternal, continents immovable, and oceans locked forever into their basins. Civilizations were built on the belief that the ground beneath their feet was stable. Cities rose, empires expanded, and generations lived and died without ever questioning the permanence of the planet itself. But this belief is an illusion. Beneath Earth's calm surface lies a restless world, alive, dynamic, and constantly in motion. The planet we live on is not a static rock drifting through space. It is an active system, driven by internal heat, pressure, and forces so powerful that they can reshape the surface of the world entirely. There was a moment in Earth's deep past when these forces nearly crossed a point of no return, a moment when the planet came dangerously close to tearing itself apart. This is the story of that moment, the day Earth almost split apart. To understand how close the planet came to catastrophe, we must travel far back in time, long before written history, before cities, before agriculture. We must return to the end of the last ice age, a period when Earth was undergoing one of the most dramatic transformations in its existence. For tens of thousands of years, massive glaciers covered large portions of the planet. These ice sheets were not thin layers of frozen water. They were kilometers thick, weighing trillions upon trillions of tons. They pressed down on Earth's crust with unimaginable force, deforming it like a compressed spring. The land beneath the ice sank under the pressure. Then the climate changed. As global temperatures rose, the ice age began to end. Glaciers melted at an accelerating pace. Sea levels rose rapidly, flooding coastlines across the world. But the most important changes did not happen in the oceans or on the surface. They happened underground. As the ice disappeared, the enormous pressure it had exerted on the crust was suddenly removed. The Earth responded violently. Scientists call this process isostatic rebound, the slow rising of land after the removal of weight. But during this period, the rebound was anything but slow. The crust cracked. Stress that had been locked away for tens of thousands of years was released. Fault lines awakened. Earthquakes became more frequent across the globe. Volcanoes that had been dormant for millennia began to stir. The planet entered a phase of instability unlike anything humans had ever experienced. But nowhere was this transformation more dramatic or more dangerous than what is now East Africa. At the time, East Africa was not the dry, harsh landscape we know today. It was a green and fertile region filled with rivers, lakes, and wildlife. Early human populations thrived here. In fact, this region is often called the cradle of humanity. But beneath this life-filled surface, something extraordinary was happening. Earth's crust in East Africa was thinning. Deep within the planet, molten rock, magma, was rising closer to the surface. Massive slabs of rock known as tectonic plates were no longer moving together. They were slowly drifting apart. At first, this movement was subtle, just millimeters per year. But tectonic forces do not need speed to be destructive. They only need time. Over centuries, stress accumulated, pressure built, the crust stretched thinner and thinner until it could no longer hold. And then, the ground began to tear. Long fractures ripped through the landscape, some stretching for dozens of kilometers. Entire sections of land collapsed downward, forming deep valleys. In other places, molten rock burst violently through the surface, releasing fire, ash, and toxic gases into the atmosphere. Volcanoes that had slept for thousands of years suddenly awakened. Lava flowed across the land, destroying ecosystems in its path. Ash clouds darkened the sky. The air became unbreathable in some regions. Rivers were blocked or redirected. Lakes drained or expanded unpredictably. This was not a single disaster. It was not one eruption or one earthquake. It was a planetary-scale crisis unfolding over generations. For the humans living through this period, the experience would have been terrifying beyond imagination. The land they depended on became unstable. Familiar landscapes vanished within lifetimes. Water sources disappeared or turned toxic. Fire erupted from the ground itself. To them, it must have felt like the world was ending. And in a geological sense, it almost was, because what was happening beneath Africa was not merely destruction. It was something far more significant. The planet was attempting to split a continent. Earth's surface is divided into tectonic plates that float atop a semi-molten layer called the mantle. Most of the time, these plates move slowly and predictably. But when conditions align, when pressure, heat, and movement combine, plates could begin to separate violently. In East Africa, this separation was accelerating. The crust stretched thinner. Magma rose higher. Fractures widened. The planet was approaching a critical threshold, one beyond which the process could become unstoppable. Had this separation continued unchecked, the consequences would have been unimaginable. Africa could have begun splitting into two massive landmasses. A new ocean could have formed in the heart of the continent. Climate systems would have been thrown into chaos. Ocean currents would have changed. Ecosystems across the planet would have collapsed. Human history itself would have taken a completely different path. But something extraordinary happened. The planet slowed. For reasons buried deep within Earth's interior, resistance increased. The rate of separation decreased. Magma supply fluctuated. The crust, though fractured, did not fully rupture. Earth came to the edge of irreversible change and pulled back, not because the danger was gone, but because the balance of forces shifted just enough. The scars of that near catastrophe remain visible today. Long valleys, volcanic fields, rift systems stretching thousands of kilometers. They are reminders that Earth is not stable by default, that continents are not permanent, that beneath our feet, forces capable of reshaping the world are always at work. The day Earth almost split apart was not a myth. It was not speculation. It was a real geological crisis, one that came frighteningly close to changing the planet forever. And it was only the beginning of the story. If Chapter 1 was a moment Earth began to tear, then Chapter 2 is a story of how close that tear came to becoming permanent. The fracture system responsible for Earth's near catastrophe is known today as the East African Rift System, one of the most powerful, complex, and dangerous geological features on the planet. Stretching for more than 6,000 kilometers, it runs from the Red Sea in the north, through Ethiopia, Kenya, Tanzania, Malawi, and Mozambique, cutting a slow, invisible wound through the African continent. This is not a surface crack. It is not erosion. It is not damage from an impact. It is Earth pulling itself apart from the inside. At the heart of this system lies the Afar region, a place so extreme that it feels almost unearthly. Temperatures regularly exceed 50 degrees Celsius. The land sits below sea level. Toxic gases rise from the ground. Lava lakes glow at night. Yet beneath this hostile surface lies one of the most important tectonic junctions on Earth. Here, three massive tectonic plates meet. The Nubian plate, carrying most of Africa to the west. The Somali plate, carrying eastern Africa. And the Arabian plate, drifting away toward the Middle East. Unlike most plate boundaries, where plates collide or slide past one another, these three plates are moving away from each other. This type of boundary is called a divergent boundary, and it represents the earliest stage in the birth of an ocean. When plates diverge, the crust between them stretches. As it stretches, it becomes thinner and weaker. Eventually, it fractures. Magma from deep within Earth's mantle rises to fill the gap, cooling into new crust. This is how oceans begin. Millions of years ago, this exact process tore apart the supercontinent Pangaea. What started as a continental rift slowly widened. Magma rose. Land split. Seawater flooded in. Over time, the Atlantic Ocean was born. What makes the East African Rift terrifying is not just that it exists, but that it is active right now. And thousands of years ago, it was far more violent than it is today. Geological evidence shows that during the late Ice Age and early Holocene period, rifting activity in East Africa accelerated dramatically. Seismic data, volcanic deposits, and rock formations all point to an intense surge of magma rising from the mantle. Entire sections of the crust collapsed into elongated valleys known as grabens. Lava flows repeatedly resurface the land. In some areas, the crust thinned to just a fraction of its original thickness. This thinning brought magma dangerously close to the surface. Pressure increased. Heat accumulated. The Earth was approaching a threshold, one where rifting could shift from slow separation to rapid rupture. Had this happened, the consequences would have been irreversible. Africa could have split into two massive landmasses. Seawater from the Red Sea and Indian Ocean could have rushed inland. A new ocean basin could have formed in the heart of the continent. This would not have been a slow, peaceful transformation. It would have triggered massive earthquakes, explosive volcanic eruptions, and catastrophic climate disruptions. Ocean currents would have changed. Rainfall patterns would have shifted. Ecosystems across Africa and beyond would have collapsed. Human history would have been rewritten. We have seen a glimpse of this process in modern times. In 2005, in Ethiopia's Afar region, the ground suddenly split open. Within just 10 days, a 60-kilometer-long fissure appeared across the landscape. Magma surged upward, filling the gap almost instantly. The event shocked scientists. Never before had such a large continental rift formed so quickly in recorded history. Satellite images showed the land pulling apart in real time. That event was only a small echo of what happened thousands of years ago. Back then, eruptions were larger. Fractures were wider. Magma intrusion was more intense. Entire regions were reshaped within human lifetimes. Volcanoes erupted in chains, releasing enormous quantities of ash and gas into the atmosphere. The land was unstable. The air was toxic. The ground itself could not be trusted. And yet, despite how close Earth came to catastrophe, the rift did not fully open. Something intervened. Deep within the planet, forces began to counteract the separation. As magma rose and cooled, it hardened into new crust, increasing resistance. The plates did not move freely. Friction slowed them down. Mantle convection patterns shifted, redistributing heat and pressure away from the rift zone. In simple terms, Earth began to resist its own destruction. The separation slowed. The magma supply fluctuated. The crust fractured, but did not rupture completely. Africa came to the edge of becoming two continents, and stopped, not because the danger was gone, but because the balance of forces changed at the last moment. The East African Rift did not disappear. It remained, scarred, fractured, unstable, a reminder that the process had begun but was unfinished. Today, that unfinished process continues. The rift widens by just a few centimeters each year, about the same speed as human fingernails grow. But given enough time, centimeters become kilometers, fractures become seas, valleys become oceans. The East African Rift is not a question of if, it is a question of when. Thousands of years ago, Earth nearly crossed that threshold. A new ocean almost formed. A continent nearly split in two. And the only reason it didn't is because the planet paused just long enough. But pauses in geology are never permanent. They are only delays. When Earth approaches a geological breaking point, the consequences are never confined to a single location. Our planet is an interconnected system, where pressure released in one region redistributes stress across the entire globe. What began as a deep continental tear in Africa did not remain Africa's problem alone. It triggered a chain reaction, subtle at first, then increasingly violent, that reshaped the planet on a global scale. To understand how close Earth came to catastrophe, we must look beyond the rift itself and examine what happened everywhere else. As the East African Rift intensified, tectonic stress did not simply vanish. It migrated. Fault lines thousands of kilometers away began absorbing the pressure. Plates that had remained relatively stable for millennia were suddenly pushed closer to their limits. Earthquakes became more frequent worldwide. Regions that today are considered geologically dangerous, such as the Mediterranean, the Middle East, South Asia, and the Pacific Ring of Fire, entered periods of heightened activity. Volcanic systems that had been quiet for thousands of years began to stir. Magma chambers pressurized. Eruptions became more explosive. This was not coincidence. As tectonic plates shifted in Africa, Earth's internal balance was disturbed. The planet responded by releasing energy wherever it could. At the same time, another powerful force was reshaping the world. The rapid collapse of the Ice Age. As glaciers melted, sea levels rose by more than 120 meters. This rise did not happen smoothly. Geological evidence shows it occurred in pulses. Sudden surges of water released as massive ice dams failed. Entire coastlines were swallowed within generations. Low-lying regions disappeared beneath the oceans. Land bridges vanished. One of the most important of these was the land bridge connecting Asia and the Americas. As it flooded, human migration routes were permanently altered. Isolated populations were cut off from one another. Evolutionary paths diverged. Rivers changed course. Coastal plains turned into seabeds. Fertile lands were lost forever. This environmental upheaval forced humanity into survival mode. Populations migrated inland or to higher ground. Some adapted, many did not. Entire cultures disappeared, leaving behind only fragments, tools, ruins, and stories. And those stories are key. Across the world, ancient civilizations preserved remarkably similar memories of this time. Myths and legends spoke of a great flood that destroyed an earlier world. Stories described fire emerging from the ground, the sky darkening, and the land shaking violently. These tales appear in Mesopotamia, India, Africa, the Americas, and East Asia. For centuries, historians dismissed these accounts as symbolic or exaggerated. But modern geology tells a different story. Science now suggests these myths may be distorted memories of real geological events, passed down orally over thousands of years. They are not precise records, but emotional echoes of a world in crisis. The Earth itself was unstable. Volcanic eruptions released enormous quantities of ash and sulfur into the atmosphere. These particles reflected sunlight, causing temporary cooling in some regions, while others experienced extreme rainfall. Climate systems became unpredictable. Seasons shifted. Ecosystems collapsed. This instability coincides with a major turning point in human history. Around this time, humans began to abandon purely nomadic lifestyles. Agriculture emerged independently in multiple regions. Permanent settlements appeared. Food storage became essential. This was not simply innovation. It was adaptation. The planet had become unreliable. Humanity needed stability, so it tried to create its own. But even as humans adapted, Earth continued testing its limits. Had tectonic stress increased just slightly more, had volcanic activity intensified just a bit further, had sea levels risen even faster, the chain reaction could have escalated beyond recovery. Earth might not have stabilized. The rift in Africa could have accelerated. Other rifts might have followed. Continental separation could have triggered additional mantle disturbances, leading to widespread crustal failure. In such a scenario, Earth would not have split cleanly into two halves. Instead, it would have entered a prolonged period of extreme instability, marked by relentless earthquakes, supervolcanic eruptions, and catastrophic climate shifts. Life would have survived, but civilization might not have. What saved the planet was timing. The forces driving separation peaked, and then began to decline. Ice melt slowed. Pressure redistributed more evenly. Mantle convection patterns adjusted. Earth's internal systems absorbed the shock. The chain reaction weakened. The planet stabilized. Not because it was safe, but because it avoided crossing a critical threshold. Earth had flirted with disaster and stepped back. The scars of that near collapse remain etched into the planet's surface. Drowned coastlines, rift valleys, volcanic fields, and seismic fault lines. They are reminders of a time when Earth came dangerously close to tearing itself apart and taking everything living on it along for the ride. This global chain reaction was not the end of the story. It was a warning, because the same forces that nearly destabilized the planet once are still active today, and Earth has not forgotten how close it came. Considering the immense forces unleashed during that critical period, one haunting question remains unanswered. Why didn't Earth fully split apart? Why did a process powerful enough to crack continents, flood coastlines, awaken volcanoes, and shake the entire planet suddenly slow down? The answer lies not in a single cause, but in a delicate balance of forces operating deep within Earth's interior. The planet is not a fragile object that breaks easily. It is a self-regulating system, governed by feedback mechanisms that can either accelerate change or restrain it. At the heart of this balance lies the mantle, a vast layer of semi-molten rock beneath Earth's crust. Heat from the core drives slow, massive convection currents within the mantle, much like boiling water circulates in a pot. These currents are the engines that move tectonic plates. But these engines do not run at a constant speed. They respond to changes in pressure, temperature, and resistance. During the period when Earth nearly split apart, mantle convection beneath East Africa intensified. Hot material rose upward, thinning the crust and feeding volcanic systems. This surge pushed the Nubian and Somali plates further apart. For a time, the process appeared unstoppable. Yet as magma rose and intruded into the crust, something unexpected happened. It began to cool. As molten rock cooled, it solidified into new crustal material. This newly formed rock acted like reinforcement, strengthening parts of the weakened crust and increasing resistance to further separation. In effect, the planet began patching its own wounds. At the same time, plate friction increased. Tectonic plates do not glide smoothly past each other. Their edges grind, lock, and resist motion. As separation intensified, friction converted kinetic energy into heat, slowing the plates down. The more the plates tried to move apart, the harder it became for them to continue. Earth was pushing back against itself. Another critical factor was gravitational equilibrium. Earth's mass is not evenly distributed. Large changes in crustal thickness or elevation affect how mass is balanced across the planet. As rifting progressed and land collapsed in East Africa, gravitational forces began redistributing stress elsewhere, pulling energy away from the rift zone. This redistribution reduced the likelihood of runaway separation. In simple terms, Earth began spreading the load. At the same time, the end of the Ice Age introduced another stabilizing influence. While rapid ice melt initially destabilized the crust, the eventual slowing of melting allowed pressure systems to rebalance. Sea level rise decelerated. The rate of crustal rebound decreased. Tectonic stress stopped accelerating. These changes acted like a brake. The planet did not return to stability instantly. Earthquakes and eruptions continued. Rift valleys remained unstable. But the system avoided crossing a critical threshold, a point beyond which continental breakup would have become inevitable. This concept of thresholds is crucial in geology. Earth systems often behave non-linearly. Small changes can produce massive effects, but only after a tipping point is crossed. Before that point, feedback mechanisms can still restore balance. After it, control is lost. Thousands of years ago, Earth approached such a tipping point and stopped just short of it. But this pause did not mean the danger had disappeared. The East African rift did not heal. It did not close. It did not vanish. It slowed. And slowing is not the same as stopping. Today, the same rift continues to widen at a rate of 2 to 5 centimeters per year. This may seem insignificant, but on geological timescales, it is relentless. Centimeters become meters. Meters become kilometers. Given enough time, resistance weakens. Reinforcement fractures. Thresholds are crossed. Earth avoided catastrophe once. Not because it was safe, but because the balance of forces temporarily favored restraint. This realization carries a sobering implication. The planet is capable of approaching disaster, retreating, and then advancing again. Stability is not permanent. It is conditional. Earth's crust today is thinner in the rift zone than it was thousands of years ago. Magma remains close to the surface. Volcanoes remain active. Earthquakes remain frequent. The system has not reset. It has merely progressed to a slower phase. From a human perspective, this feels reassuring. Generations pass without dramatic change. Cities stand. Borders remain intact. The ground seems stable. But from Earth's perspective, nothing has stopped. The clock is still ticking. The forces that nearly split the planet are still at work, slowly testing resistance, gradually weakening barriers, patiently building toward another critical moment. Earth did not fully split apart because it was not ready. Yet, the question that remains is unavoidable. After everything Earth has already done, after coming so close to tearing a continent apart, could it happen again? The honest answer is unsettling. Yes, because the forces that nearly split the planet thousands of years ago are not ancient memories locked in stone. They are still active, still moving, still shaping the world beneath our feet. The East African Rift did not end. It merely slowed. Today, the same tectonic plates continue to pull apart. The Nubian plate moves westward. The Somali plate drifts eastward. Between them, the crust stretches thinner year by year. Beneath this thinning crust, magma remains dangerously close to the surface. Modern instruments confirm it. GPS measurements show plate movement of 2 to 5 centimeters per year. Seismic sensors record frequent earthquakes. Satellite data reveals the ground rising and falling as magma shifts below. Volcanoes such as Erupted remain active, maintaining persistent lava lakes that testify to the immense heat still trapped within the earth. From a human perspective, these changes feel slow, almost insignificant. But geology does not operate on human timescales. Given enough time, centimeters become kilometers. Given enough pressure, resistance fails. Given enough instability, thresholds are crossed. Scientists estimate that within 5 to 10 million years, Africa will split into 2 distinct landmasses. Seawater from the Red Sea and the Indian Ocean will flood the rift, forming a new ocean basin. Eastern Africa will become a vast island, permanently separated from the rest of the continent. This is not speculation. It is the same process that created the Atlantic Ocean. The difference is timing. While the final breakup lies millions of years in the future, localized disasters do not. Earthquakes can strike without warning. Volcanic eruptions can accelerate suddenly. Rifts can open in days, as they did in Ethiopia in 2005. Human civilization, for all its technology, remains fragile in the face of such events. Our cities are built on the assumption of stability. Roads, pipelines, power grids, and communication networks all depend on predictable ground beneath them. Agriculture depends on consistent climate patterns. Global trade relies on intact coastlines and navigable seas. Earth has never promised any of these. History shows that when geological systems destabilize, they do so unevenly. One region may collapse while another remains untouched. Survival becomes a matter of location, timing, and preparation. And Africa is not the only place where Earth is under tension. Across the planet, other regions show signs of strain. The Pacific Ring of Fire remains the most seismically active zone on Earth. The Mediterranean region sits atop complex fault systems capable of major earthquakes. The Himalayas continue rising as India presses into Asia. The Yellowstone volcanic system holds enough energy to reshape an entire continent. Earth is not approaching a single global disaster. It is approaching multiple localized thresholds. The lesson of the past is not that Earth will suddenly split apart tomorrow. It is that change can accelerate without warning. Thousands of years ago, Earth nearly crossed a critical threshold. It paused. It stabilized. But that pause was temporary. The process continued at a slower pace, invisible to human eyes. Today, humanity stands in a unique position. For the first time, we can see what Earth is doing. We can measure plate movement, monitor magma chambers, track seismic waves in real time. We understand the mechanisms that drive planetary change. But understanding does not equal control. We cannot stop tectonic plates. We cannot shut down volcanoes. We cannot prevent continents from moving. What we can do is recognize the warning signs. The day Earth almost split apart teaches us that the planet operates on forces far greater than civilization. Continents are temporary. Oceans are born and destroyed. Climate shifts dramatically. Life adapts or disappears. Human history occupies only the final seconds of Earth's timeline. The planet existed for billions of years before us, and it will continue long after us. The question, then, is not whether Earth will change again. It is whether humanity will learn to live on a planet that never promised stability. Because when Earth decides to reshape itself, it does not negotiate. It does not slow down for borders, cities, or civilizations. It simply follows the laws written deep within its core. The day Earth almost split apart was not an anomaly. It was a reminder that beneath our feet lies a restless world, one that has come close to tearing itself apart before, and will one day finish what it started. As we reach the end of this story, one truth becomes impossible to ignore. The earth beneath our feet is not silent. It is not asleep, and it is not finished changing. What we witnessed in this documentary was not a prediction. It was a reminder that continents are temporary, oceans are born and destroyed, and the surface of our world is constantly being rewritten by forces far older and far stronger than humanity. Thousands of years ago, Earth came frighteningly close to tearing itself apart. The signs were everywhere: cracking land, rising magma, collapsing coastlines, violent eruptions, and a planet struggling to regain balance. Humanity survived not because it was prepared, but because the planet paused, just long enough. But geology does not forget, it does not forgive, and it does not stop. The same tectonic forces are still active today. The same plates are still moving. The same rifts are still widening. The same magma is still rising beneath the surface. The process that nearly split a continent has not ended. It has merely slowed to a pace that feels invisible to us. And that is what makes it dangerous, because slow change creates the illusion of safety. We build cities. We draw borders. We plan futures, assuming the ground will remain stable. But Earth has never promised stability. From its perspective, human civilization is brief. A single moment on a timeline measured in billions of years. Mountains rise and disappear. Seas advance and retreat. Continents collide and tear apart. Life adapts or it vanishes. The lesson of the past is not fear. It is awareness. Understanding how close Earth came to catastrophe helps us understand the world we live on today. It reminds us that natural disasters are not random. They are expressions of deep planetary processes unfolding over immense spans of time. And while we cannot stop these forces, we can respect them. We can prepare. We can learn. And we can remember that we are guests on a planet that was alive long before us and will remain alive long after us. The day Earth almost split apart was not the end of the world. It was a warning, a quiet reminder written into stone, fault lines, and fire, that the planet beneath our feet is always changing. And one day, when Earth decides the time has come to finish what it once began, it will not ask whether we are ready.